If you like today's presentation and you want to see some previous ones, we have Michael over here. He does a podcast for us, so you can go listen to the podcast. We've got videos on YouTube. You can watch some previous presentations. But today we've got Rand Voorhies. So he's the CTO and co-founder of inVia. He's previously at JPL. He's going to talk about robotics and AI. Very fascinating stuff. Very excited to have him. Please welcome to the stage, Rand.
Hey guys. So I'm Rand Voorhies, CTO of inVia Robotics. So we build robots for e-commerce. So maybe to give you guys an idea of what that means, it's best to always start with a video. So let's check this out, and then I will tell you about how we got here, and then what our challenges are, and what running a robotics company today is like. Cool. Okay, so how do we get here? So back in 2015, my co-founders and I had just graduated grad school, and we knew that we were passionate about robotics, and we wanted to start a robotics company. So we thought really hard about this, and we came up with one rule for ourselves, was that we didn't want to start a robotics company that was selling toys or some kind of novelty or a demo or just making YouTube videos. What we wanted to do is start a robotics company where we can make a pure economic argument to our customers, where our customers would come to us and say, you are a good opportunity for us because you cost less than anything else. We didn't want this to be some kind of flashy, riding on the wave of cool robots or whatever, just a pure economic argument. So we started looking around at a bunch of markets. And while we were doing this, we sort of thinking with our hands, building prototypes, trying things out. And the first thing we tried out was we said, there's a huge market in assisted living. We had read this news story that showed that in Japan, I think a year later, it was projected that adult diapers were going to outsell baby diapers. And just indicative that there's a huge upcoming problem in Japan in terms of assisted living. And so we looked at this market and said, hey, there's got to be something we can do here. Maybe we can build robots that would help people out here. Feel very good about ourselves. If we can make this an economic argument, this is going to be awesome. So we built a bunch of prototypes. We built some very inexpensive arms, tried a bunch of things, had a robot that was, opening the microwave and trying to put, microwavable meals in and get bottles of water and this kind of thing. And unfortunately, one of the things that we realized was that for a large amount of money, say $30,000 to $50,000, we could build a robot that could do maybe 10% of the things that needed to be done in assisted living. So sure, we could get a bottle of water. Sure, we could maybe pick something up off the ground that was dropped. We couldn't help somebody tie their shoes. We couldn't help them in and out of the bathtub. We couldn't help them do all sorts of things that somebody in assisted living would really need. And if you're going to be paying that much money for the help, you can just have live-in help or whatever, or live in a facility, and we really couldn't make an economic argument out of this. So as we were building a lot of these prototypes, we built up a machine shop in the classic startup garage, and building sheet metal and plasma cutting parts and trying to put together this prototype. And as we were doing this, we were ordering parts off of Amazon. And constantly astounded, we would order like some esoteric motor driver, and it would come the next day. Or we'd order a 7x6 sheet of 1/8-inch aluminum, and that thing would come individually wrapped the next day, free shipping. How are these guys doing this? What is happening? And it felt like this sort of happened all of a sudden. And I suddenly realized also that I didn't really want to go to the store anymore to buy toothpaste. I just wanted to sit on my couch and order it online. So we really started thinking about this, started looking at Amazon's model, and started thinking hard about e-commerce. And the first thing we realized was that e-commerce is absolutely exploding. The market is just getting huge. Everybody is moving towards this model of buying things online. And we also realized that there is a huge labor shortage. Unemployment was starting to go down at the time, a trend which has really continued. And we started getting into warehouses and just talking to people. And one of the things that I learned to ask very early on when I meet a warehouse manager and he'd show me his operation, I'd say, hey, man, how's your temp force these days? He'd say, oh, yeah, we're at like 60% temp labor right now. You know how it is. We're going to get it down by peak, but, it's hard as usual. And so we thought about that and saw, okay, there's a huge push from the economy towards e-commerce, and there's a huge need here. This has got to be something we can solve with robots. And so we looked at warehouses. Warehouses are great. They're typically flat, typically very neat and ordered. There's boxes. Said, okay, this looks like a great opportunity for robots. So we started thinking about, okay, why is this happening? Why is this different than what's been going on before? And so the old model was you, the consumer, would go to a store, you'd have your shopping list, and you would do essentially the random access through the store. So you would walk through the aisles, pushing your shopping cart, picking up the items you want. And what the store was responsible for was bulk access. We're all computer nerds, so we think about this thing in terms of RAM and hard drives. So previously, warehouses would have distribution centers, and they would ship pallets of things across the warehouse. And see, there's a guy driving a fork truck here, and he has maybe $30,000 worth of items on his forklift. And so you can think about the dollars carried per foot traveled is really high for this guy. So he's making one trip across the warehouse and he's bringing maybe $30,000 worth of stuff. That pallet goes to the store and gets unloaded, and then you are doing all of the random access, right? And that's a great model for the stores. It's very labor efficient for them. And so now we're all ordering our toothpaste online, and somebody still has to do that random access. And right now, e-commerce companies are traditionally solving this just brute force. They essentially give your shopping list as well as maybe 30 other people's shopping list to somebody with a cart, and they walk through these enormous stacks of product and walk and doing all of that random access for you, the consumer. And somebody has to pay for that energy. And right now it's the e-commerce companies, because everybody's being driven down by Amazon, right? Amazon's free shipping. Next day, they're driving it lower and lower and lower and putting pressure on everybody. So this looked like a problem that we could solve with robots. It's essentially moving and grabbing simple things. So things that robots are really good at are traveling really fast, grabbing really simple stuff, and coordinating very, very tightly. Things that robots aren't good at are identifying complicated objects, picking objects that are, not square or cubes, and, for instance, detangling things from each other, any kind of fine manipulation. So the way I think about it is that feet are very cheap to replace. Hands and eyes and brains are not. So we thought, okay, what can we do to make it so that people just do not have to walk? All they're doing is they're using their brains, they're using their eyes, they're using their hands constantly and never having to walk. So our solution was you can think of it as a small robot shuttle with a very, very simple gripper that can just grab a box. And our whole job here is to make it so that these people are not walking. And essentially, their job is now, instead of walking 10 miles a day, they're essentially teleporting from place to place to place to place in the warehouse. And as soon as they grab something out of a box, put it in the order bin, as soon as they turn around, boom, the next box is there for them. So that's the idea. And there's a lot of sounds like a very straightforward, simple idea. There's a lot of things that make this fairly complicated. So one of the big things that we've learned here is that we really can't just be a robotics company. When we started this, we were under the assumption that we would make the hardware, we'd probably write the firmware, we'd probably write the control software that ran on the robots, and we'd probably write some coordination software for those robots. But the rest, I'm sure that customers can tell us which boxes to bring and when. And, the rest will be just kind of some glue, no big deal. It turns out that we're not quite at that point yet. I sort of think of this as the 1950s pre-computer revolution, right? These days, in terms of personal computers and in terms of just general personal computing devices, it's great, right? Everybody has a personal computer. Everybody has a phone or a laptop or whatever. And there's now this like app ecosystem where you can be a hardware company and you can just make phones, you can just make tablets, you can just make whatever, and you can be very, very certain that people are going to come along and write apps for your device. There have been a lot of robotics companies that have failed because they've tried this model. They said, okay, we're at like the 1995 of the robotic revolution here. We're going to make a really cool robot. An app ecosystem is going to evolve, and then people are going to buy our robots like crazy and install all these apps on them. And they never really thought about step two, which is how do you get the critical mass of that ecosystem? How do you get enough roboticists out in the world building things for a big enough market? So we thought about this, and after interacting with a lot of customers, we determined that we really cannot just be a robotics company. We have to be a solutions provider. So that rather than marketing our product as, hey, we make robots, would you like to buy them? What we say, our marketing strategy is more, how much are you paying for labor? Would you like to pay less? And so that requires a very different mindset and a much, much deeper both technical stack and expertise stack in terms of how we have to build our company. So, you know, we now have to deeply understand all of the workflows that go on in a warehouse. We have to understand what intake means. We have to understand what pack out means. We have to understand what cycle counting is, which is, you know, every so often you have to do an audit of all your inventory. And so customers want to not just pick things, but bring robots around to count all the items in the boxes. They have returns. They have all of these different things that all basically boil down to robots bringing boxes, but we can't phrase it that way. We have to phrase them as discrete individual services that we offer to the customer and really kind of white glove the entire thing for them. And the reason here, again, is because there just aren't a lot of roboticists out there. Our customers are logistics experts. They're labor management experts. They're product experts. They're not robotics experts. So if we come to them with a very technical looking product and say, here's our robot, here's these specs, here's how many meters per second it can drive, here's the payload capacity, whatever, they're not interested. But if we say, you're currently paying 75 cents per pick, we can do it for 30, they're interested, right? But the rest of those details really need to be handled by us. So this means that not just we don't just have to build the robotic stack, we also have to build the entire application stack on top of this. And I think this is one of the really important things that robotics companies are learning right now, is that selling robots is really hard. Selling services is hard technically because you have to understand a lot more things, but from a sales perspective, it is a lot easier, and the sales cycle is a lot shorter, and it's much easier to onboard customers, if you're really selling the entire service, and they can just think about it like a service. So, and that's why robots as a service is so key here. It's not just a good economic model. I mean, it makes a lot of sense. You currently spend this much OPEX, operational expenditure, on labor. We can cut that down, and you can now redivert that operational expenditure budget to us, and we will do more with less, and everybody's happy, and you don't have to get a huge capital expenditure approved by, say, your board or whatever. So robots as a service works really well in terms of getting that sales cycle fast for financial reasons, but it also aligns everybody's interests really well so that we're not just dropping robots off in crates at a customer's door and saying, you know, call tech support if anything goes wrong. Instead, we provide this whole solution Or we actually do remote monitoring. Any problems with the robots, we try to take care of remotely before the customer notices anything. Any upgrades, any repairs, we just take care of it all because our customers tend to be very, very intolerant to any kind of technical problems. And that's one of the big things that we've learned here. So it actually works very well because it drives us to make sure that we're aligned with solving the customer's actual problems rather than just like building the products that we want to build because our customers pay monthly here. And if we're not satisfying their needs, they can just cancel their contract. So it very much aligns us to make sure that we're solving the robot need, or solving the customer's need. And then technically, it's a tough business. We just hired our VP of Ops we poached him from Verizon, and this guy was responsible for maintaining all of the servers in Verizon CDN service. So tens of thousands of servers all across the world. We have a small fraction of the number of robots, on the order of hundreds, but he says that this job, managing robots, is just significantly harder than managing built-in racked servers. So we really have a lot to learn about how to do this. We're learning some very interesting and difficult lessons in how do you maintain robots with junky power sources that can die mid-upgrade, that are on spotty Wi-Fi, not jacked into some backbone fiber connection in your data warehouse or whatever, that have hardware probably that have belts that slip and wheel bearings that fail and all this kind of stuff. So we've had a lot to learn about fleet maintenance and software fleet maintenance and how do you upgrade and maintain all of these things across many different warehouses where we may not have remote hands that are owned by for instance, if you're running servers, they'll often have a service where you can have some guy go and, de-rack a server, swap the hard drive, re-rack it in 30 minutes or whatever. We have warehouses out in Tennessee, where if anything goes wrong with that robot, we just got to crate it up and send it back. So, there's a lot of really unique challenges, hardware and software kind of maintenance-wise, that make it tough. And also, robots are hard. Robots interact in the real world. So, unlike a typical software application where you can maybe get a stack trace and reproduce the problem and, try to solve it at your desk, with robots, it's very difficult. We've had problems where like one beam of light will shine on just a couple pixels of one sticker and will completely ruin the whole image processing pipeline for ridiculous reasons. And these kinds of things are really hard to predict and really hard to test for and to build, kind of nice unit test suites. And also, a lot of this stuff happens at really high rates, really deep down on the robot hardware. So I don't know how interested you guys are in the technical aspects of that. So feel free to ask me a ton of technical questions in a minute if you guys want to drive in that direction. Cool. So what makes this all so interesting? We started a robotics company because we didn't want to go build a traditional company. We wanted to do something exciting. So we're really building a new market here. Warehouse automation is super new, and we're having to do a lot of education of customers, which is hard. But it means I get to go out and I get to talk to a lot of people and evangelize for robotics and why this works and why, get into these cool philosophical discussions about why I think this is actually good for society. I think this is a good thing for us to be doing. And obviously, technologically, there is a ton of really cool stuff going on. So really happy to talk shop and nerd out. I am, of course, a technology person, so feel free to dive as deep as you guys want on technology questions or business questions. Obviously, the technology questions are my forte, but happy to answer anything. Cool. So that's about all I have. Happy to answer, again, any questions you guys have. This looks like it's going to be an interesting crowd for a good conversation.
We always have the best questions. Thank you, Rand. So we'll open up to Q&A. This is a great time to ask about Rand's background, the future of robotics. Not a great time to talk about your experience with robots and how they've ruined your life. Anything like that, not a good time. So I'm going to pass the mic to John. Raise your hand if you got a question. There you go. Start over here.
Hey, great presentation, thanks. I would assume that as you're trying to figure out what your robots are going to do, that you need to interact with a person on the floor there whose job is going to be lost when the robot replaces him. Have you run into that challenge, and how did you deal with it?
Yeah, surprisingly, it's been much less of an issue than I thought. So when I went to my first warehouse with my first crates of robots, the night before I couldn't sleep. I was afraid that I was going to have a lot of confrontations, and it was going to be a lot of hard conversations about exactly that. And when I got there with a truckload of crates of robots, all of the warehouse workers all came and were super excited to help me unload the truck, unbox everything. And before I knew it, they were all bringing their kids by and taking pictures. And we learned something really important about the types of teams that run warehouses. And typically what happens, as I kind of alluded to at the beginning of this, warehouses typically will have a small core full-time staff of people who work there. And then they simply can't find enough full-time people. They cannot. The unemployment rate is just way too high or way too low. And so what they do is they fill in all of that need with temp labor. And temp labor is really tough. You have generally a brand new group of people who have never seen your warehouse before coming in at, say, 8 a.m. and they're going to leave at 5. You got to get them trained. You got to get them aligned. You got to get them pointed in the right direction. You got to get them productive before they go home and you never see them again. So what we found was that we would have really good reception from this core group of people who work at the warehouse full time. And are excited to reduce their reliance on temps, because honestly, there's always a little bit of malcontent between the full-time workers and the temps, because full-time workers are, working hard, and they often see these temps as coming in, not really knowing what they're doing and kind of getting in the way, and then they never see them again. So they see us as coming in and empowering them to do their job and take over all the operations of the warehouse.
Over here, Ryan.
Yep. So I'm curious how you've identified your potential customers, and if you could give an example of a company that has adopted your technology and just how that's improved their operations.
Yeah, definitely. There is a kind of a new class of customers that's really interesting for us, and it's called a 3PL, a third-party logistics company. And a way to think about it is if you're shipping gold bars, right? And let's say you're making huge margin on some iPhones or gold bars or whatever, and it costs you $1 versus $1.50 per pick, but you're making $200 per thing that you ship, you don't really care, right? That percentage of your margin, you don't really care. So what we're looking for is people with lower margin businesses. And one great example of this is this third-party logistics company that what they do, they don't make anything. All they do is they manage warehouses. And so if you make, say, mugs, right, pottery mugs at home, if you sell these on Etsy or whatever, you don't really want to be going to the post office every day, mailing out 10 mugs here or there. But what you do is you make 100 mugs, you'll ship them to your 3PL, and you'll hook them up to your order processing system. And so when somebody orders one of your mugs, it gets routed to the 3PL. 3PL knows where that is in their warehouse, and then they fulfill it. And what's great about that for us is their entire thing is just selling the service of picking and fulfilling items. And so this is actually a really cool model, and it's getting much bigger and bigger and bigger as the need for shorter delivery times is dropping. So maybe 10, 15 years ago, a consumer might tolerate you selling them a mug, and then you get around to shipping it a week later, and, it's shipping from across country, and, maybe they get it 9 days later or 10 days later. These days, somebody orders something, they say, 10-day shipping, let me see if it's on Amazon, right? So everybody's being driven to figure out how to ship things very, very quickly. But most companies don't have the infrastructure to have a West Coast, a Midwest, and an East Coast warehouse all running full-blown operations to fulfill stuff.
Thank you. Right over here.
Looking at the warehouses and that, there's a fairly broad ecosystem to get the robots to work. The layout of the warehouse, the labeling, the boxing, and all of that. How far does your solution, do you provide the services to help them do that, or do you try to adapt to what's in place?
Yeah, so we adapt to what's in place, meaning that we almost never require customers to buy new racking or to buy new totes. Those are the boxes the product go into. But we do require, I don't know if you may have noticed in the video or some of these pictures, we have these stickers everywhere, and we have stickers on all the boxes, and we do that because it makes the processing very, very inexpensive. We make the robots very cheap if we just put those stickers everywhere. So we do all that right now. So we have a full-time deployment team that basically flies around to all the new deployments, spends about a weekend with these huge, rolls of sticker tape and just rolls them along the racks, and then sticks a sticker on every box, and then goes on to the next deployment. So we do that right now. One of the things that we're really excited about, and our kind of dream, is to have a Buy It Now button on our website, where you hit Buy It Now, all of the robots get boxed up, go out to the customer along with a giant kit and a set of manuals of here's how you lay out the stickers and here's how you do it all yourself. So that's the dream. We're doing it all kind of more white glove right now just to make sure that it's all done correctly. And we're constantly changing our procedure and our process. So we just do it right now and eat some of that cost or bake it into the contract for now.
Over here.
Hey, Rand. Thanks. Great presentation. Really impressed with how you guys figured out how to shift your business model to be more of a service platform. I can imagine that was a lot of stress to take a big bet on that. You keep referring to Amazon. Are they the gold standard? Are they the company to beat? Or are they the company that you feel you can surpass? Like, how does Amazon play into your vision for the company?
Sure. Amazon is our best friend. I wish all the best to Amazon. Because what Amazon is doing, if Amazon didn't exist, we would go to a customer and say, hey, we can take 50% off of your shipping costs. Hey, we can get your shipping costs down from 5 days to 1. And they would say, yeah, okay, sounds okay, but we're kind of happy with our pen and paper right now. There would be no pressure. So what Amazon is doing is providing that market pressure that is stepping on all of our customers to actually need us. Because otherwise, we operated for years and years and years with super slow shipping, ordering stuff from catalogs, and it was all fine. Society kept chugging along. We were okay. But now that Amazon is showing people the shining star of next day shipping for free, or make you think it's free, everybody wants it. And now all of a sudden, it's not just a want, it's a need.
Up front.
You said you're focusing basically on automating feet because it's the lowest hanging fruit, and I certainly agree. But there's a lot of people who are also trying to automate the eyes and the brain and the hands. So you're in a race with them, and maybe you can't talk about what you're doing internally to cope with that, but I'd be kind of curious how you're handling that as a business. Are you saying, look, whoever figures that out is probably going to be 10 times our size because it's that much more difficult to question. Therefore, a Google or Alphabet or somebody, they'll buy us. We don't care. Or we have a Skunkworks project. We're working on that. I can't tell you about that or whatever. I'm kind of curious what you're thinking about the future.
Yeah, I can tell you all about it. It's right now, it's truly an economics argument. This is how we just phrase in all of our management meetings. We just talk about the money. Does this make sense monetarily for us? And right now, it doesn't. Simply the cost of robot arms right now and their reliability, and it's less the arms, meaning the shoulder and the elbow joint. It's more the processing of how do you recognize what's called the grasp points of random objects. It's a very difficult computational problem. And we're not quite there yet. But we're getting really close. So we're starting to partner with a company that does exactly this, and we have a pilot rolling out soon. And this is something we may start investigating ourselves as well to try to do. But it's basically as soon as our level of comfort with the reliability of that procedure and meets up with how much customers are willing to pay is when we will pull that trigger. But it's certainly a really, really enticing goal here. And it's what we call the lights out warehouse, right? Where the idea is the warehouse is some giant machine with basically a bunch of gears that you never go into. And there's a bunch of things happening in there, which would be our robots and a robot arm, where our robots are bringing the box around to the arm, and the arm is grabbing all the stuff out. But it's all totally autonomous. There's no lights anywhere. There's no air conditioning. There's no HVAC. There's nothing. So we still think that our model, the way we've designed the system, is simply the first piece of that, and that it doesn't make sense to put a $5,000 arm on every mobile robot. We still think the way to do it is to have a couple expensive arms, all stationary, where the robots bring the products to them. And there's some good statistics about the order profiles that makes this a really good idea.
Bring a bin of jumbled items.
Yeah, exactly. Yep.
Hey, Brandon. I think I heard one of your talk before in Caltech Entrepreneur Forum.
Yeah.
So today, I think you talk a lot about the business point of view, I think. So my question is, from technical point of view, what is the most challenging point in terms of, for example, hardware or software, based on your experience, like working in the warehouse delivering solutions?
Sure. Yeah, when we started this whole thing, I kind of assumed that the hard part would be the robots. That, the computer vision and the control algorithms and the localization algorithms would all be what we would be struggling with for a long time. Turns out that we actually slammed all that together pretty quickly. And really the hardest part is what one might think of as the boring stuff, which is, how do we integrate with customers? It turns out that every single customer has a different warehouse management system software. And there's a couple big vendors out there, the JDA, there's Manhattan, there's a couple big vendors out there. But essentially what these companies do is they sell you like a database and a manual, and then you have to hire a team of people to come actually build your application up from the ground up for every single warehouse. It's sort of like if Salesforce didn't have an application, they just had Force, and every time you wanted to install it, you had to hire a team of people to come build up Salesforce for you. WMSs are sort of like that. So every single customer is like totally different. And one of our big challenges was building a piece of software that could translate between any WMS out there. People have homebrew stuff, people have first-class stuff, people have 30-year-old stuff, people have, Excel sheets that they do everything on. So building a piece of software that can actually flexibly translate between our system, which needs things in a very rigorous, very particular way, because we're dealing with robots, and communicate with this nebulous, who knows, WMS system out there. So that was one of the biggest challenges for us, which it sounds pretty boring, but it's actually, coming from a robotics company, but it's actually a super interesting problem. We've had to build some very cool software to do that.
Hi. I believe you said it was a month-to-month contract with the client, so I was wondering where the capital came from to buy all these robots.
Yeah, definitely. Like I kind of said, we're pretty much done with the technology and the product development here. We have some kind of bells and whistles and other things to develop, but the product is very solid. And what we're doing now is we're iterating on our sales strategy, and we're doing R&D on our sales strategy and what really makes the most sense both for the customers and for us. And we've tried a lot of things. We've tried a just pure per pick. You pay us 25 cents per pick or whatever. And we've tried monthly fees. We've tried we've sold robots before. We tried all kinds of different things. And so we're now kind of iterating and refining these sales strategies to see what works well. And where we've landed right now is really the per month works very, very well. And essentially what we do is we don't talk about per robot, we talk about per line per hour. So we're essentially selling the bandwidth of the system. And that tends to be a message that resonates very well, and it aligns us with the customer for a variety of reasons that we could get into later. But to answer your question, robots aren't free. Somebody has to build that hardware at some point. So first of all, you need a lot of investment to build a hardware company. And the other thing is that because we're selling hardware, we're not just making code, we're not just making apps or whatever. We have physical hardware. It's a lot easier to get debt financing. So we can go to banks, and banks can look and say, okay, you have 1,000 Core i5 computers in these robots. Cool, yeah, if we need to repossess those, I'm sure, yeah, that makes fine collateral. So it makes it a lot easier to get debt financing, which is really powerful for a hardware business like ours. And it's a really great tool that we've used pretty effectively.
Right in front.
Currently, how many people do you have in your company, and what does it break down in roles, and where are the opportunities for growth?
Definitely. So we are about 65, pushing 70 right now. So my engineering team is 10. So I have one mechanical engineer, I have one electrical engineer, and everybody else is software. Our operations team, we have 2 DevOps, full-time DevOps members, and then I think 10 members of what we call our ROC. I don't know if you've heard of a NOC, a Network Operations Center. We have the ROC, which is our Robot Operations Center. And these are the people that, if a robot throws up an error flag, that gets communicated back to the ROC, and they can log in and see if they can deal with that problem or pull the robot out for maintenance or whatever. And then we have about 15 back office. We have HR, we have accounting, all that stuff. And then the bulk of the remainder is all assembly. So we build our own robots. Everything is designed in-house. Everything from the circuit boards to the scissor lift to the actuators, everything is all done in-house because anything we can find parts for that are economical enough, of course, we'll use. But generally, the robotics space is filled with parts that are meant for high precision, low volume parts. There's not a lot of high volume robot parts out there for startups like us. So we build everything, which means that we have to not only do intake and all of our inventory management, and then assembly, and then QC. And so we do all of that in-house, and that's actually the bulk of our company.
Over here.
Okay, a couple of my questions are sort of answered. So I wanted to know if you manufactured your own robots, and then are they all one size, and how much can they carry in weight?
Yep, so they are all one size. We have looked at different models of trying to build different size robots. The XL, the Econo line, the whatever. And we felt that it was better for a small team like us to do one thing and do it really, really well.
Okay.
We were afraid of spreading ourselves too thin. And so we designed the payload capacity of the robot, which is 40 pounds, around a big survey of every customer we could talk to about how much they loaded their totes. And pretty much everybody, 80% of their warehouse is under 40 pounds. And so that's what we do. We're trying to hit the biggest possible market with the smallest possible hardware footprint. We will probably expand. We've had a lot of people asking if we can go to 16 feet, if we can carry 80 pounds, if we can do whatever. And we always say yes, but not now.
And then, is this all one company, or are you profitable, or do you have separate companies that all go? Because it's a lot of different departments that you're actually got under one umbrella.
It is a very deep stack, right? So yeah, it's all one company, and it's a very tight crew. We're still very much in expansion mode. So we are trying as hard as possible to grab as many customers as possible. Our fear here is that it will be a land grab, that somebody else will come along and eat up a bunch of that market. So we're trying to expand just as quickly as we can to get our foot in everywhere. But yeah, we have to do it all, which oftentimes feels very wild. I thought I was going to get into this just like nerding out on robots and, writing some code and whatever. And before I know it, I'm on the phone with warehouse management system executives talking about integration plans and all this kind of stuff. So yeah, it's indeed quite a deep stack.
Over here.
I apologize, I came a little bit late. Hopefully I didn't miss this already, but talk about the international context, specifically pick out the biggies, say China, Russia, India, Europe. Is there competition that you're seeing from these other countries, intellectual property protection? And also, since we're in the election cycle, debates last night and so forth, speak to, talent procurement. Do you feel like the U.S. educational system is providing the talent that you need?
Yeah, definitely. So some interesting things are happening internationally. So I don't know if you guys are familiar with Kiva. Kiva is a company that does something sort of similar to us. Instead of picking the boxes, they just pick up the whole shelf. And they got bought by Amazon in 2012. And they have a very strong patent portfolio. We don't do what Kiva does because, A, we don't think it's a good idea, or we think our idea is better, call it hubris or whatever, but we think it's a better idea. But also, they have super strong patents about how they do that. However, those patents either aren't filed or aren't enforced in China and India and some places in Europe. And in those places, you see copycats. So there's a couple companies abroad who are, it looks like they read the Kiva patents and hired a bunch of engineers and said, build that. So that's really what's happening abroad. What was your other question? Oh, hiring. Yep. Yeah, it's a good question. Yeah. I surprisingly see a lot happening in China. China, the Chinese government seems to have a really big push and is really getting behind a lot of high-tech companies. What's interesting about that is right now at least, I don't really see the labor push, the labor pressure that we do here in the U.S. I don't think the economics are really the same in China, meaning I think you can stock a warehouse full of full-time employees in China and you won't see the same pressures that you see trying to do that here. They're doing really, really cool stuff and their systems are very impressive. So I'm interested to see where their funding is coming from and really how all that's getting driven.
I'm sorry, can we ask that question over here? Thanks.
Very good presentation. I'm very impressed how you got to the compelling story. My question is, in terms of your software, do you buy software off the shelf to do what it is that you want it to do, or do you actually write the software to do what you want it to do? Does that make sense?
We write everything, we design everything, we build all of it. Yeah, we rely on a decent amount of open source software. I don't know if you're a deep nerd, but we use like OpenCV, we use Boost, we use a lot of open source software. But all of the specific problems that we're solving, there really is no software out there that solves our problems. So we have to build it all from scratch. And even, unfortunately, the academic papers that claim to solve a lot of the problems that we have, like, for instance, traffic routing 200 robots in a tight warehouse where you're trying to get as many boxes as possible with the smallest aisle space. Routing 200 robots efficiently so it doesn't turn to like the 405 on Friday evening is a just brutally hard problem. And there's very few academic papers that even talk about this, and the ones that do don't actually really solve the real world problems. So we have to do it all. And it's everything from there to writing firmware to writing WMS integration code. So yeah, we do it all.
Thanks for the presentation. My name's Edward. So a few questions. One is, what does it cost? And what is a typical return on the investment for the solution provider or for the solution?
Sure. I don't think I can tell you what it costs. I can tell you that the robot costs themselves. I'll tell you that I I don't ride bikes, but I have a lot of friends whose bikes are more expensive than our robots. If that gives you an idea. Our cost per month per customers, I also can't share just because we're currently exploring that, and everybody gets a slightly differently negotiated contract right now. But we have to make it competitive. So we go into a customer, we do an analysis, we say, how much are you spending right now? Let's look at where that labor breakdown is. And then we cut it down by enough margin to make it interesting to them. So sorry, I can't be any more specific about that right now. At some point, we'll have that buy it now button on the website, but...
But what about the return on investment? I mean, are you looking at being have like a 12-month time, ready break even, 2-year time?
Oh, it's basically in a month. Yeah. It's as long as we don't have to do any kind of weird custom integration or anything we have to charge NREs for, which we just really try to avoid. Yeah, I mean, you're paying us per month, and we're going to output this, and you're immediately going to save money in the first month. So yeah, it's a no-brainer sale. Once we convince them that this works and they understand what it is and that the integration is going to work and all this, the sales cycle is just really easy.
Back here.
So just my follow-through question from earlier. So, political context, do you, as an employer of, high-tech people, do you feel like there's enough people available out there? Do you think we need to have more STEM programs? Can you just talk about the educational talent out there?
Yeah. So if I want to find a applications engineer, if I want to find somebody who can write web code or back-end code or kind of traditional high-tech company stuff, it's awesome. It's very easy. I can put out a call to recruiter and have 10 Django programmers in an hour. It's great. Hiring roboticists is a different story. It is really, really tough to find robotics engineers. There's just really not a lot out there. The ones who are and have actual industry experience are being tightly held on to by their wherever they work. So it's really tough to find roboticists. I have more or less stopped trying to hire specific roboticists. And now what I say is, look, I need you to be great at Python. I need you to know C++ very deeply. I need you to know these libraries. And I need you to be willing to solve hard problems and dig into frustrating stuff because robots are tough. It's unlike anything you've ever done. You got to be excited. You got to have an awesome attitude. You got to be willing to really dig into hard problems. And that's it. No robotics experience necessary. I'll teach you whatever you need to know about the math or the science behind robotics. That's not the hard part. The hard part is the grit and the determination to just keep going. So on a positive note, though, I started to see more and more younger people coming out of high school and now college who've gone through the first robotics program, which is awesome. I don't know if you guys know about this, but it's basically a high school competition program where kids get together, they build robots, often out of Legos or, kind of snap together parts, and sometimes even do a little machining, and then build these robots for a competition. It's usually some kind of ball game. You have to pick up a bunch of balls here and throw them through a hoop and then push this block into that block, that kind of thing. But it's getting kids kind of acclimated and used to the kind of thinking that has to go into robotics, which is a really good sign. It's a huge program, and the things that they're doing are really cool. So I think the future looks really bright. It's kind of tough right now, but I think in 10, 15 years, we're going to see a huge wave of roboticists coming out of these things.
Thank you so much for the presentation. Being a robotics company, especially now that you're planning on growth and expansion, do you have any robots in your own assembly line for making robots, or is it everything happening manually? And where do you see that in future?
Yeah, right now it's all manual. It's all about volumes. So our volumes are low enough right now, and our process is changing fast enough that robots don't really make sense. So we treat, much to the chagrin of my hardware team, we treat our hardware the same way we treat our software. We run agile sprints for hardware, and every single batch of robots that comes out is a slight improvement over the one that came out before. Okay, that bracket isn't quite strong enough. Cool, scrap it. Let's make another one. The batteries aren't in the right spot. No problem. When you try to swap the batteries, you're banging your knuckles on this thing. Cool, let's change it. So we iterate constantly. So our assembly team is really good. And basically every single batch that comes through has a new set of assembly instructions, which is a really tough thing to automate. Eventually, yeah, we'll definitely get there. And we're starting to automate some of the super repeatable things, like we do our own camera calibration. Every camera that comes in, we get these very inexpensive lenses that have all kinds of distortions and all kinds of junk in them. And so we wave a known pattern around them in a known way, and then we can build a model of that lens. And so that kind of stuff is very easy to automate, but reading the instructions of, okay, you know, now this nut has to go on this side because previously people were banging their knuckles on it or whatever is really tough to automate. So not yet, we'll get there.
Last question.
Yep.
So many questions. You sell your robots, or do you lease them? And if you have a swarm of robots, are you responsible for the upkeep and maintenance?
Yeah, so we do everything as a service. We explored the sales model at first, and it just really didn't align things. People were very afraid of getting these robots, us dropping them off, and then saying, see ya, you know, we'll expect a check in a week or whatever. So we do everything as a service, and it's very much a managed service where the way we think about it is if we replace those robots with people in robot suits, the customer shouldn't care at all. Maybe they think it was funny or whatever, but or if we found a way to hire and run a temp labor force in a more efficient way and reliable way, that our customers shouldn't care because they're just paying us per the throughput of their warehouse. So we do all of that. The robots are owned by us, they're maintained by us, and they're managed by us. Simply because customers aren't roboticists. There's a lot that goes into managing and maintaining these things. And so it just aligns everybody's interests way better if we do all of that. Yeah, cool.
Thank you, Rand. Great presentation, great questions.